Okay, so here we go. This is the Unit 5 review, and there will be some questions on Hawks that when you're taking the test, it's going to say, do this without a calculator. I'm begging you, okay? Well, anytime you're doing a question, even if it is with or without a calculator, write down some work. Some of the questions that you guys have turned into me, no work has been written, and so I'm like, So when I go to grade your exam, I need to see the work. So number one, the very first one, it is P of X equals 2 to the x minus 3. And the instructions here say to graph. And so what we're going to have to do is we're going to have to make sure that we understand and that we realize as this function is written, this is an exponential function. Okay, for the time being, there's no log part, there's no log in this. It's just an exponential function. And so we know that if our a value is greater than 1, it's an increasing function. If it is less than 1, then it is a decreasing function. Something like that. Actually, that's not true. Something like this. Okay, and so we're going to say, all right, well, our a value in this case is the number 2. And so we'll put 2, which is greater than 1, so we know it's going to be an increasing function. And we also know that because this is an exponential function, that the y-intercept is 0, 1 of the parent function. And then I look back and I say, okay, are there any transformations happening? What does this tell me?
Right 3.
Right 3. Right 3. And so if I start at the point 0, 1 and I move right 3, where am I at?
3, 1.
Okay, so I'm at 3, 1. And so 3, 1 is going to be the point which I draw my line through, and there's no other transformations, and it's an increasing function. So I will go over 3 and up 1. And remember, when we're doing this in Hawks, all we have to do is pretty much this. Because then remember, they're going to give you 4 graphs to choose from. And maybe one looks like this, and maybe one looks like this, and then maybe you have the right one, and maybe you have, I don't know, this one, something crazy. All you have to be able to do is find this point and say, oh, here you go. And you're going to click on that graph, and then you're going to be done. So on your paper, I would like to see, this information so that you can actually find this point. All right, so what are your questions on number 1? All right, then I'm going to keep going. So number 2 says to solve the following elementary exponential equation. And we have 5 to the negative x equals 125. And since the problem actually has the word expo right in it, in words, I mean. And so this is not a log problem. And so we're going to say, hey, look, this is base 5. Is there any way that I can take the number 5, raise it to some power, and that equal 125?
Yes.
Yeah, what's that number?
5 cubed.
5 cubed, exactly. So what we're going to do is, on the left-hand side, 5 to the negative x will stay exactly the same. The number 125 will turn into 5 cubed. And say, hey, look, now I have the same bases. And once I get the same bases, I take these exponents and I set them equal to each other. And so I will have negative x equals 3. But I don't want negative x. How am I going to get x by itself? I'm going to divide by negative 1. And so my x is negative 3. And now I'm done. Questions on 2? Okay. Number 3 is similar. Okay, again, the instructions say to solve the following elementary exponential equation. So again, you see the word exponential right in there. And the problem is 2 to the 5x minus 3 equals 1/4. And when we talked about these last, we mentioned that we don't want any fractions for bases if we can help it. And so this is a base 2, and we know that base 2 is not going to change. So what I need to know, is there any possible way that I can turn 1/4 into 2 to the something? That's what I need to know. And so over here on the side, I'm going to say, okay, well, if I had 1/4, isn't that 1/2 squared? And if I have a number that's in the bottom, how do I get it up to the top? Well, don't I take this exponent and I make it negative? Yeah. And so what's going to happen is we're going to say, of course, on the left-hand side that 2 to the 5x minus 3 stays the same. This 1/4 becomes 2 to the negative 2. And now I don't have to worry about this. And I say, okay, well, since my bases are the same, I'm going to take these exponents and I'm going to set them equal to each other. And then I'm just going to solve that new equation. And so what I'll have is I will have 5x minus 3 equals negative 2. And then I will add 3 to both sides. And I will get 5x equals 1. I divide both sides by 5, and x will be 1/5. Done. All right, what are your thoughts on 3?
Not bad.
Not bad. Okay, so, excuse me, number 4. This is going to be a given equation. So this is number 4, and they're talking to us about blood concentration or a drug's concentration in our bloodstream. And they say that the formula given is C of T equals 0.08 parenthesis 1 minus E to the negative 0.2T. And then it goes on to say, what is the concentration after 14 minutes? Round to 3 decimal places. Well, they're telling us that T is equal to 14. All we have to do, literally, is take this 14, put it here, and put it right there. So we will have C of 14 equals 0.08 parenthesis 1 minus E to the negative 0.2 times 14. And then we're going to type this right into our calculator. And so if you have your calculator in front of you, which I highly recommend you having it so we can practice these things, you're just going to type, your 0.08, your parenthesis 1 minus, you're going to hit your E button, a parenthesis will pop up, or maybe the caret button, whatever. Then you're going to type negative 0.2 times 14. Then you're going to use your arrow button to come down, and then you're going to hit enter. Okay, and however you do that, whatever you type in, or excuse me, however you have to type it in for your calculator, the answer should be 0.075. So take a sec, make sure that however it is you're typing it in, you're getting 0.075. So I'll wait a second, you try it out, see what happens. Okay, any questions, any problems with number 4? Anybody not able to type that in? I need to know now.
Nope. Just got to remember the extra parentheses for the E.
Yes,
For the
yes,
exponent.
yes.
Because that's always what gets me. I don't put them in and then it changes the whole answer.
Yes, it does. And it's unfortunate because, everything else will be right, except, this is going to look way off. And I'm going to be like, but they forgot the parentheses. And that's what's going to have happen. So, yes.
I've just been multiplying the numbers first and then typing what I got.
Absolutely. Yeah, because that's what we do in our compound interest problem. So, absolutely do that first. Yeah, that's perfect. Okay, so number 5. Let's take a look. Number 5. Now we're going to do some investing. Okay, so you invest $5,100 into a new savings account, which is 4.8% is your interest rate. It is compounded continuously, so compound continuously. Okay, what will your value be after 2 years? And so time is 2 years. So here's everything that we need to know. And so what we're going to do is we're going to go ahead and say, all right, well, I have 5,100. So that's my p-value. My interest rate is 4.8%, but I now have to turn that into a decimal, so 0.048. Compounded continuously, that's the PERT formula. And time is 2 years, T is equal to 2. So all I have to do is take this information and put it into that formula. So I'm going to have 5,100 E, and I'm going to raise that up to the RT. And so I think it was Taylor who said, let's take the R and the T and let's multiply it together first. That's a great idea. So let me do that because I haven't done that yet. What do I get? 0.096. So I'm going to raise this to the 0.096. And this is what I type into my calculator. And then I hit enter. And when you do that, the answer that you should get is $5,613. And we're going to round it off to the nearest cent, so 87 cents. So take a second, make sure that when you type this in, this is what you get. I need to know if it's not happening. All right, I'm going to assume the silence is okay. Okay. All right. Number 6. It's another compound interest problem. So you have inherited $5,400, okay? And you want to deposit it into an account. And you have 2 options. So option 1, option 2. Let's see. The first option, and it compounds semi-annually. So semi-annually, N is 2. And your interest rate is 3.1%, which we have to turn into a decimal, so 0.031. And I didn't notice this at first until Ashley asked me. On the blank one, I didn't have a chance to write on there, but on the key, the question's actually after 2 years. So if you didn't get that one, that's on me. I didn't have that written out. The second option is a problem that, or is a bank that compounds continuously. So we'll jot that down. Compounds continuously, and the rate is exactly 4%. And again, time is going to be 2. And so on each of these instances, the amount of money that you're putting in is still 5,400. So your p-value is still 5,400. And so what we're going to have to do is we're going to have to use both compounding formulas. And on this one, since we have an n value, we're going to use a equals p times 1 plus r over n to the nt. And on this one, since it's compounded continuously, we're going to use the PERT formula. And so now it's just a matter of taking everything that I've been given and plugging them in. And so over here, I will have 5,400 parenthesis 1 plus my rate, which is 0.031, over my n value, which is 2. And here my n times t is going to be 4. And so this is what I type in. And so what I should get on number 6, part A, or bank 1 rather, is 5742.66. So here's what I should get for the first one. So make sure that you do. Okay, and then I'll type it, and then I'll write over here on the second one what I should get. I'm going to type it into this formula. So I will have 5,400, not 5,000. 5,400. I'm going to times it by E. And in this case, my R times T is going to be 0.08. So to the 0.08. And so again, this is what I type in. And when I type that in, what I should get is $5,849.75. Okay, so we got to make sure that we're getting these numbers. And then, of course, once you get these numbers, what I want to do is I want to choose the bigger one. And so in this case, my answer, because on Hawks, they're going to ask you bank 1 or bank 2. You're going to have to just click, but I need to see this work. And so you're going to click, in this case, bank 2. And it's because this is a bigger amount. So let me give you a minute. Look at this. Let me know what you think. So any questions, any problems with this?
No.
Okay. Now, if you looked at the blank one, there was a step 2, but I crossed that out on the key, so don't worry about the step 2. So if you tried it and you don't worry about it, I'm not going to be asking you that. Okay. All right. So then that means we're ready to move on to number 7. And so number 7 is another graphing function. However, as soon as you see this, you're going to realize, hey, look, there's the word log. So it's graph this, log base 1/3 of x plus 4. And so the first thing that we have to realize in this instance is that, hey, this is a log problem. And so it's not just a regular exponential function. It's going to be kind of upside down, so to speak. And so we know that if our a value is greater than 1, that it is an increasing function. We know that if our a is less than 1, it's going to be increasing. We know it's going to be a decreasing function. So in this case, our base is 1/3. So 1/3 is less than 1. So it's going to look something like this, some type of a decreasing function. Now, the next thing we have to pay attention to is, are there any transformations happening to this function? So I go back over and I look and I say, hey, look, what's this telling me?
Up 4.
It's telling me up 4. So I also know that because this is a log function, the point, so to speak, it's no longer 0, 1 that I'm looking at. The x-axis, the x-intercept rather, is always going to be for a log function 1, 0. So if I start at the point 1, 0 and I go up 4, so where does that put me if I start at 1, 0 and I go up 4?
1,
4,
4.
0.
Okay, so I'm getting 2 different answers. I'm starting right here and I'm only going up 4. So that should put me up the point
1, 4.
right? Okay, so my new point, and remember, I really only need my new point, is 1, 4. And I know it's going to look like this because no other things are happening to it. So I'm going to start at 0, 0. I'm going to go right 1, and I'm going to go up 4. 1, 2, 3, 4. And I know that it should be a decreasing function like this. And so I'm just going to draw my decreasing line through it. And that's going to be all I need. Because again, on Hawks, you're going to have 4 different graphs. And they're going to say, hey, look, maybe here's this one. Maybe it's decreasing, but it's over here somewhere. Maybe you have this one, but it's actually increasing or something. I don't know. And then this one looks crazy. And then, oh, look, here's the one I need. And this is the point that you're looking for. So again, it's super important that you can find this point. Because when you're doing this on the test, because it's given to you in Hawks, I need to see some work, and then you're going to click, oh, look, here's that point. It's this one, done. Now, the main thing here that we have to remember is whether it's an exponential function or whether it's a log function. Okay, so literally, if it's log, it's going to say log. So what are your thoughts on number 7?
Good.
Okay. All right, so then let's move it on to number 8. Okay, so 8, 9, and 10 and 11. Yeah, 8, 9, 10, and 11. These are problems that you should be able to do without a calculator. So it asks you to evaluate this without a calculator. And the problem is log base 2 of 8. And so this goes way, way back to when we first learned about logs. The first thing that we did was we said equals y, because we needed to equal something. Because if it doesn't equal something, then we can't draw our arrows. And so once we have it equaling something, we hit the arrow here and we hit the arrow here. And then that gives me an exponential function that says 2 to the y equals 8. And so quickly, I just say, hey, 2 to the what gives me 8. Done. So if this was Hawks, what I need to see is you write down the problem, which I wrote in black. You're going to insert your equals y, draw your arrows, write your exponential function, and then solve the problem. So what are your thoughts on 8?
Those ones are quick.
They are quick. Yes. All right, so then let's keep going then, okay? And if we come across one that's like, woo, then we'll look at it. All right, same thing with number 9. You're going to evaluate this without a calculator. And so we have log base 8 of 1. Well, the first thing that we have to do is we have to make it equal something. So we're going to say, all right, equals y. And then we draw our arrows. And then that gives me an exponential function. 8 to the y equals 1. And what's the only exponent that when you raise something up, it equals 1? Well,
0.
Yeah, 0. The one that works for every single number. So ta-da, done. Y equals 0. Questions on this one? All right, so now number 10, this is the one that looked a little weird. Okay, so we have the ln of, and then we have the 8th root of e to the 6th. And this is what it looks like. And way over here on the side, we're doing a little side note. We said way, way back that when we have the square root of x, it's really x to the 1/2, which means the square is outside and the 1 is inside. And so what I want to do is I want to take this big thing right here and turn it into a fraction. So this is going to become the ln of e to the what? What's going to go on top?
6 over 8.
6 over 8. And we know that when we take the ln of e, what happens?
It's log.
Okay, it is log, but generally
But you can get rid of the ln and the e.
exactly. The ln of e is actually 1. And so what we're allowed to do here is, guess what? We're just going to focus on this fraction. Well, we're going to have 6/8. You guys know me enough to know that anytime you see a fraction, you want to try to simplify it. 3/4. That's it. I'm done. Don't overthink these. Okay, I'm not trying to kill you guys. I just need you to understand the rules of logs. So my final answer is 3/4. So whatever number you're given, right here and right here, you're going to turn it into a fraction using this idea that x squared, or excuse me, that the square root of x is 1/2, so that you can, know where to put your numbers. Whatever that fraction is what you're left with. Simplify it down. Done. Any issues or questions on number 10?
No.
It's not as bad as what it looks like because it looks kind of bad. All right, number 11. Again, it's the same type of a problem. We're going to evaluate this without our calculator. We have log base 1/4 equals 64, or excuse me, oh my goodness, of 64. And so the first thing we're going to do is say, okay, equals y, and then we're going to draw our parentheses. And that's going to give me 1/4 to the y equals 64. Okay, now, it's very tempting to grab your calculator, okay, but we're not going to be able to, or I'm not going to want you to do that. So here's what I would want to do. I want to forget the idea for a moment that I'm dealing with a log. This is just exponential stuff. Is there any possible way that I can take 1/4 and 64 and turn them into the same base? Meaning, is there some number that I can raise up and that equal 1/4, and then that same number I could raise up to a different power and that equals 64? That's my question.
4 cubed.
Okay, 4 cubed. So we can do 4 cubed. All right, fine. Well, how about 1/4? Can I do 4 to the something and that's going to give me 1/4?
And -2.
How about just -1? All right, so let me erase some of this and rewrite it. So what if I say, all right, I'm going to scooch over here. We're going to say 4 to the -1 is actually 1/4, but that's still being raised to the y. And we're going to say that 4 to the 3rd is 64. Everyone agree to that?
Mm-hmm.
Okay. And so now we have the same base. And so we're allowed to take our exponents, which in this case I have a power to a power. And over here I just have 1. And so we're going to say negative 1y equals 3. Now I don't want negative y. I need positive y. And so what am I going to have to do here?
Divide by 1.
Well, what kind of 1?
Negative 1.
And so my answer is y equals negative 3. And now I'm done. So when you go to do these problems, I don't want you guys to overthink these and turn this into something terrible, because it's not, right? Just say, all right, rewrite it like this, get your basis, figure out, if you looked at my key, I happen to use a 2. We could have used a 2 as well. In this case, you guys said, let's use a 4, so I did. All right, so what are your thoughts on 11?
Not bad.
All right, so then number 12, it says to solve this, and we're gonna, you're gonna be given the boxes on Hawks that's gonna say exact and then decimal approximation. So we have the ln of 6x plus 9, and that equals 2. And so before we can draw our arrows, we need a base down here, which we don't have. And so what am I turning that into?
E.
So log base e, and the rest of this for the time being hasn't changed. And now I have a base, and I can draw my arrows, and I'll say that e squared equals 6x plus 9. Now you have to use your calculator on this one, but not until the very last step. Okay, so the first thing I want to do here before I use my calculator is get this x alone. What am I going to have to do in order for that to happen?
Minus 9.
Okay, so that's going to give me e squared minus 9 equals 6x. Okay, well, my x is still right here. So what do I have to do?
Divide by 6.
And what I do to one side, I have to do to both. And so what's going to happen is, again, in Hawks, you're going to be given 2 boxes like this. Okay, and this is going to ask you for your exact answer, and this is going to ask you for your approximation. And so my exact answer is x equals e squared minus 9 over 6. So any issues on this? My exact answer.
No.
All right, so then what I'm going to have to do is I'm going to have to type that into the calculator. And so if you have your calculator, here's what you're going to do. You're going to hit the E button. The little caret thing's going to pop up. You're going to put a 2 in there. You're going to scooch out using your over button or however you have to do it. Then you're going to hit minus 9. I'd like you to hit enter first. Then the division button, then 6, then enter again. And the answer that you should get when you type all of this in is 0.27. So take, or excuse me, negative 0.27. My goodness. Tell you what, let me get a darker color. I don't know why I'm using yellow. Take a second and make sure that you are able to get this. It's negative 0.27. And so these two pieces together are what you're going to type in Hawks and what I need to see on your paper. So any issues, any problems with number 12?
Mm-mm.
Let me check the little chat button, see if anyone's chatting me. Because they're being awful not chatty today. Okay. All right, so let's keep going. So then 13, let me turn my page here. Number 13, it's asking us to, again, solve a log equation. And so here's the problem. We have log base 5 of 2x minus 1 equals 2. And so since we already have only one log, and this is going to be very easy for us to draw our arrows. And we'll say, okay, well, 5 squared equals, I can't read my own writing, that's a 2x minus 1. And then now this is just a nice little equation that we know how to solve. Well, we know that 5 squared is 25. And so that means that 25 equals 2x minus 1. Well, now I'm going to add 1 to both sides. 26 equals 2x. I divide both sides by 2. And x is 13. Done. Okay, what do you think?
I like those.
I like those too. I really like logs, just in general. So maybe I'm a little bit biased. I don't know. Okay, so then let's keep going. So 14 asks us to use the properties of logs to expand. And so when we talk about expanding, we are given 1 and we want to turn it into many. Okay, and so the problem is the ln of, and on the top I have 14x squared, and on the bottom I have y to the 5th. And so I am trying to expand. And so I have to look in here and I have to see, okay, well, a couple things are happening. Between the 14 and the x, there's a multiplication sign. And then since this is being raised up, I know eventually it has to come out front. And then I see a division bar, and then down here I see another number that needs to come out front. And so my first line of expansion is going to be the ln of, and since these two are being multiplied, what am I going to turn that into?
Plus.
Plus. So I have the ln of 14 plus the ln of x squared. Okay. And then I see a division bar. And so the next thing I need to write is a
Minus ln to the y5.
Perfect. Okay, so now I have it expanded. And so then I have to go through and I have to simplify each little piece as much as I can. So the ln of 14, that's nothing. I mean, no, let me back that up. It's not nothing, but I can't expand that any further. So ln of 14 stays. My plus sign stays. Hey, look, where's this guy have to go?
To the front.
So 2 ln of x. And then I truck along. There's my minus sign. Oh, hey, look, where's this guy go?
Right.
And then that's it, right?
Mm-hmm.
So the problems that are going to be on the exam are not going to be any more complex than this. They're not going to be those big ones that we did in the notes. They're going to look very similar to this. So what are your thoughts on 14 with expanding this thing?
Good.
All right. So then number 15, we're going in reverse. We're going to be given many, and we're going to turn into one. We're going to condense it. Okay. So here we go with 15. So we need to condense. So we need to go from many to one. And so here's the problem. We have the ln of 14 plus 2 ln of x minus 4 ln of y. And so as I go through this, I read from left to right. And so the first thing that I see is an addition sign, which I'm going to turn into multiplication. And then I see this front running number, and I know that he has to end up back here somewhere. And then I see the subtraction sign, which means I have to turn it into division. And then I see this front runner number, which means he has to come back here somewhere. And so when I go to rewrite this, I'm going to have the ln of, well, since this is going to be what's being multiplied, I'm going to have 14 times x. But since I know this guy's coming out back, or up top rather, how about if I just go ahead and do that and say x squared?
Mm-hmm.
And then as I see this, my division sign, oh, look, division. And then I know that this 4 is going to come back here. And the only thing that's in this parenthesis is y. And so I'll just make my parentheses a little bit bigger here. And I'll say y to the 4th. And then this is going to be it. So there's not a lot of work necessarily. I mean, I literally just went from the question to the answer. Okay, but I have to know the reasoning. So if you take a look at number 14 problem and you take a look at number 15's answer and vice versa, very similar. Okay, super duper similar. All right, so what are your thoughts on 15?
Simple.
Mm-hmm.
Okay. All right, so if you look at 16 and 17, some of us on the worksheet that we turned in, which by the way, I'm in the process of grading the 7.5s. I'll get those out back to you today after class. Anyway, 16 and 17, both of these are change of base problems. Now, if you look at the instructions, they don't say that. It doesn't say use change of base. It just says to evaluate. So here's what's
I
going to
have a
happen.
question.
Yeah, go ahead.
Is 7.5 worksheets due tonight, though?
Yeah.
Okay.
Okay. All right, so let's see, this is number 16, and the problem says log base 5 of 181. Now let's pretend for just a second that you don't realize this is change of base, because if you look at the problem, it doesn't say that. So here's what you might do. You might say equals y. You might try to draw your arrows. You might say 5 to the y, and you're going to get here, and you're going to say, huh, because you're going to be typing 5 to the 1, 5 to the 2, 5 to the 3. This isn't going to work. And so when you do this and you're like, oh, crap, it doesn't work, that's when you're realizing, hey, I got to do something different. And that something different is the change of base. Okay, so we're going to do change of base. And does anybody remember what that's going to look like?
It's log of x over log of b.
Perfect. So we'll have log of x, in our case 181, over log of, in our case b, which is 5. And then we're going to type this into the calculator. Okay, so you're going to type log of 181, then hit enter, then hit divide by log of 5, then hit enter. And when you do that, I can't remember what I got. What you should get is, let's see, 3.23, because it's going to say around to however many decimal places. So make sure you can do that. Or if you're like me and for whatever reason you're obsessed with the ln, same thing. ln of 181 over ln of 5 is going to be 3.23. Doesn't matter if you choose ln or if you choose log, but you have to be consistent. You can't have ln on top and log on bottom. All right, what are your thoughts on 16? Change of base. Any issues, any problems? All right, well, guess what? 17 is the same exact type of a problem. Okay, the problem is log of 1/7 no, excuse me, log base 1/7 of 0.306. And again, if you try to draw your Y and draw your arrows, you're not going to get that. Okay, and so we're saying, all right, well, this is change of base. And we need to remember that the base is the small number because we literally call it base, and then this is my x. And so we're going to have log of x, so log of 0.306 over, whoops, oh my gosh, I almost wrote ln, over log of 1/7. And when you type this into the calculator, you should get 0.61. Okay, so just because this is a decimal and a fraction, I don't care. I'm still going to do it the same way. So take a sec, practice typing this in, make sure you get this, because I know that sometimes when we have decimals and fractions, we get crazy and we can't type them in right. So make sure you can. So any problems, any issues with 17, let me know. Okie dokie. All right. So number 18 is one of the chemistry problems, so to speak, where we're trying to find the pH, I suppose. Is that what it is? Oh, no, this is one. Yeah. Okay. So somewhere, and I don't have my formula sheet right in front of me. You guys are going to want to make sure that you get that written down, and I'll remind you. Okay. So number 18 tells us in the problem that the H3O plus concentration equals 5.35 times 10 to the negative 1 moles per liter. Okay. And we want to know in this particular problem, what is the pH of whatever substance we're dealing with. And the formula for pH is pH equals negative log of this H3O plus business. And so all you have to do, okay, I'm going to write it in red because this is what I would expect to see on your paper. I would expect to see pH equals negative sign log, and then your H3O content, so 5.35 times 10 to the negative 1. You're going to type this in. Make sure that this is the negative sign, not the subtraction sign on your calculator. So you're going to hit the negative button, the log button, 5.35 times 10 to the negative 1. Come down out of there with your little arrow maybe, parenthesis, then hit enter. Okay, regardless of how you're typing it in, what you should get when you round it is 0.3. Make sure you're getting that.
Yeah.
Okay, if you are, just hang back for a second. Let's make sure. But that's it. So again, if this was the exam, I expect to see, I only really need to see this. I don't need you to write the problem down, okay? But I expect to see this work. Because what if you put, I don't know, for some reason, what if you just put a whole 3 here? Did you forget your decimal? Did you guess? I'll never know unless I see your work. So please, please, please write this down. All right, let me see what we got here, Chad. Yeah, so like, and what we did was we rounded that 0.27 up to 0.3. So you're right, we're just going to round it up. That's why it's important to show your work. So if you would have on the test typed in 27.2716 and given me that as your answer, of course Hawks is going to count it wrong. But when I go back and look, I say, oh, you just didn't round, and I'll count it right. Okay, so just show me everything. All right, any other problems or issues with number 18? All right, so then if you take a look at number 19, number 19 is talking to us about earthquake. And in the problem, let's see, I lost my page here. It says that the earthquake is 6,000 times more intense than whatever. And it asks me to find the Richter scale, the measurement on the Richter scale. Well, according to my formula, Richter is R equals log, and then it has I over I sub 0. Okay, but on this one, the I sub 0 doesn't really matter. We're not ever really going to use it. Okay, and I hate to scratch it out because that's not the true formula, but we only have one number, and that number is going to go right here. So again, if this was the exam, in red is what I would expect to see on your paper. I would expect to see R equals log, and then in parentheses 6,000, and then you're going to hit enter, and it asks you to round it to, I think, 1 decimal point. So you're going to get 3.8, and that's it. This is what I expect to see. So type it in, make sure you get it, and that's it. Any major issues with number 19? All right. So number 20, we're going back to some equations here to solve. And so number 20 says to solve the following exponential equation. Okay, so we have x no, we don't, excuse me. We have 8 to the x plus 3, and that equals 1842. Now, the last problem that we did like this, we said, okay, well, if 8 is our base, maybe that'd be fine. But is there any way that we can take these two numbers and make them find the same base? A little tip of a little like a winky that you can't see my face is generally when you have a large number like this, the answer is no, you cannot do that. And so when we cannot make the bases the same, what we have to do is we have to bring the ln into the problem so that I can get my x out of the exponent. And so the first thing I'm going to do is take the ln of both sides. And then by doing that, because this is now a log problem, this little guy right here is allowed and has to come out front. So I will write that as x plus 3, now as a normal number, times the ln of 8 equals the ln of 1842, like that. And then I say, okay, well, the x that I need is stuck right here. It'd be super cool if this ln of 8 wasn't there. Well, guess what I'm going to do? I'm going to divide. What I do to one side, I'm going to have to do to both. So the ln of 8 is gone. And so what I am left with, let me get my box over here. So what I'm left with is x plus 3 equals the ln of 1842 divided by the ln of 8. And so then I say, okay, well, right here's my x. And the only other thing I need to do is get rid of this 3. Well, I'm going to do that by subtracting. And again, what I do to one side, I have to do to both. And so the exact answer that I'm left with is the ln of 1842 over the ln of 8. And remember, this minus 3 is a big minus 3. So this is my, that's exact answer that you would type into HAWX, just like this. And then it goes on to ask you for your decimal approximation. And so for, this is number 20, the decimal approximation is 0.62. So take a sec, okay, ask your questions, but make sure that you can type this in right here and that you're getting this number. So what are your thoughts? What are your questions on number 20, having done all of that manipulation to get x by itself?
So if we're able to see the big number, we'll just know that you have to switch how it's.
Yes, because
Okay.
99% of the time, the big number like that, the reason why it's so big is kind of like, hey, it's not going to work, bring in the ln. It's kind of like
Okay.
a little flag, so to speak, to tell you, hey, look, this isn't going to cut it. We got to use the ln.
All right.
Okay, so what else, guys? Because we're almost done, really, and I haven't had a ton of questions, which is good, but I just need to make sure that you're understanding. So anything else on this one? Okay. Alrighty then, let's do 21. So 21, if I can get there. All right, 21. This one is a big log equation, and it says to solve. And so I have log base 5 of x minus 1 minus log base 5 of x minus 4, and that equals the number 1. And so we know that we cannot solve a log equation until we only have one log on either side. And so when I look, the first thing that I notice is, well, crap, I got 2 logs. And so in order for me to go from 2 logs to 1 log, I have to condense. And since this is a subtraction sign, what am I going to turn this problem into?
Division.
Division. And so what's going to happen is I will have log base 5 of x minus 1 on top divided by x minus 4 on the bottom, and that will still equal 1. And so now this part I don't care about right now. I'm focusing on this guy. And so now I have a base, and I have stuff in the middle, and I have it equals, and I just have 1 log, so I'm good to go. I'm good to draw my arrows like I have been. And so what's going to happen is I will have 5 to the first, which I know is just 5, equals x minus 1 over x minus 4. And so now, again, I'm just trying to solve this guy. And so generally speaking, when I have a fraction, like I do over here, and I don't want a fraction, how do I get rid of that fraction? Anybody remember? I put
Times
it
it by the denominator.
yes, and I multiply it by its denominator. And what I do to one side, of course, I'm going to have to do to the other. Now, since this is just 5 to the first, I don't really care about the first. I know it's just 5. On my right-hand side over here, these are going to cancel, which is exactly what I wanted. So I'm left with x minus 4, that whole entire thing times 5. So I have to distribute 5 times x, 5x. 5 times negative 4, minus 20, equal sign. Over here, the bottoms are gone. I'm just left with x minus 1. This is just a nice, neat linear equation. No big deal. So I'm going to subtract x from both sides. I'll get 4x minus 20 equals a negative 1. I will add 20 to both sides, and I will get 4x equals, what, 19? And then I will divide, and at the very last, I'll get x equals 19 over 4. Now, before I circle this, what's the only thing I have to check for here to make sure that the number that I got is not what?
You can't simplify it.
Okay, can't simplify it, but remember, we're not allowed to take the
Negative.
negative, right? So the only thing I gotta do is say, oh, look, it's positive. And so this is my final answer, 19 over 4. Done. Now, what if, just for kicks and giggles, what if this would have been a negative 19/4? What would I have written instead?
No
Undefined.
solution.
No solution or undefined, yes. Okay, so take a sec. I'm going to erase the stuff that's not true. Look over this problem. What are your thoughts? Because that's it. I'm done. 21, done.
So what if that 5, like what if instead of it equaled 1, like say it equaled 2 and that 5 was cubed, or if that 5 was squared,
Yeah.
how would you then distribute it, like 5?
Okay, so I'll do this in this orange, okay, so you can see it. So this would have been, okay, wait, hold on, let me check the chat and see what's going on. The only thing that would have been different, Sebastian, I think 24 or 25. It's going to be about the same length as this study guide. Sydney, the only thing that would have been different is had this been squared, then the square would of course stay there, and we would just said, okay, well 5 squared is 25, and so we would have said, oh, this would be 25x, and then 25 minus 4 is negative 100. That's how you would have done it.
Okay.
Okay. All right. Okay. So, any other questions on 21? All right. Cool. All right. So then let's. Did I cut somebody off? No. Okay. So then let's look at 22. Okay. So 22 is asking me. You're saving up for a down payment on a car. You currently have some money, but if you could have a little bit more money, you would have a better interest rate. Your interest rate is 4.5%. It's compounded monthly. How long is it going to take you to save up that amount that you want? So the first thing we're going to do is we're going to list everything out that we know. So we read this problem again. Donnie is saving up for a car. He currently has $4,640. Which variable? Okay, we're using compound interest, and so which variable represents how much you have? P. Your principal. So 4640 is how much you have right now. If you did have $5,279, that's going to be A. That's how much you want in the future. That's your future value. It says that the interest rate is 4.5%, which again, we know we have to put into decimal form, so 0.045. It's compounded monthly. How many compounding periods are in a month? How many compounding periods are in a year? I'm sorry. 12 if it happens monthly, yep. And the question is how long? So T is question mark because I don't know that. Now, the other day, I gave you guys a weird little poem that sounded kind of stupid and didn't make a lot of sense unless you knew what this problem meant. Does anybody remember how it goes? It says, when you need to find the time, what are the 3 steps?
Divide, log, divide.
Perfect, you guys. Okay, so we need to find the time. And so what we're going to do is set up our problem. We're going to divide, take the ln, and then divide. And then that's it. And so since we have an n value, the formula that we have to use is the compound interest formula that looks like this. A equals P, parenthesis 1 plus R over N to the NT. And so we're going to take this formula, and we're going to plug in everything that we know, and we'll do our divide, ln, divide, and we'll have our time. And so here we go. So we have A, which is 5279. And then that equals my p-value, which is 4640, parenthesis, the number 1, plus the rate, which is 0.045, over my n value, which is 12. And then, of course, when I do my 12 times t, it's just going to have to stay 12t because I don't know the time. And so here's my function, or here's my equation, rather, all set up. Are there any issues with getting this thing set up? All right, so here's my little poem, divide, ln, divide. And so the first thing I have to do is divide. And so I need to get rid of this whole number. So I will divide both sides by 4640. And you're going to notice that I don't touch my calculator yet. So this 4640 is gone. So I've divided. Check. Any issues with that? So in fact, what I'm going to do, because I'm going to erase some of this. So I've divided, and that 4640 business is gone. Any issues with that whatsoever? Okay, so the next step is to take the ln. Well, I can do that. I will put the ln right here. Here's me taking the ln. Here's me taking the ln. Okay, check. Now, the whole reason I took the ln was so that this exponent could do what? Where do I need that ln to, or where do I need that exponent to be?
On the outside.
On the outside as a normal number. So let's do that. Let's make it happen. So this won't be there anymore. It'll be on the outside of this ln as a nice, neat, normal number, 12t. Okay, so I divided. I took the ln. The last step to do is divide. Well, now the t value that I want is right in here, but at least it's a normal number now. It's no longer an exponent. And so my last step is to just divide. And so I need t by itself. So I'm going to divide both sides by every single thing that's being multiplied by t, which is going to be the number 12, which is going to be the ln of all of this stuff. I don't care what this stuff looks like. I just need to get it out of there. And so by doing that, this 12 is gone. All this ln business is gone. And of course, I have to do it to the other side. So I will have 12 ln 1 plus 0.045 over 12. And so my exact answer after all of that is t equals the ln of 5279 over 4640. Now this problem looks bad, okay, but really we only did 3 steps, and I will divide that by 12 times the ln of 1 plus 0.045 over 12, like that. And then I'm going to tell you what the answer is, and so you can make sure that when you type it in, you get that, okay, because typing it in is half the battle. So when I type it all in, I should get 2.87. So take a sec, see what you get. Ask your questions. So that little poem, it makes sense now, doesn't it? When you need to find the time, divide, ln, divide. And that's exactly what we did. Now remember, when you're using your calculator, you're going to want to put plenty of parentheses. So you'll need a set of parentheses here. Then you'll hit enter. And then you will hit the division button. And then a parenthesis, and you'll type 12 ln. A parenthesis will pop up. You'll type all this in. You'll close it off with 2 more parentheses. Then you'll hit enter. So anybody not able, I just need to know if you're not able to get it. Because if you're getting it, that's great. If you're not getting it, we got to make sure you are.
Let me try one more time. I didn't get
Absolutely.
it.
Okay, I'm not in a hurry. Take a sec, see what you think. Anybody else having an issue or problem with this?
Yeah, I am.
Okay. Which calculator are you using?
The TI 30X2S.
Okay, so I'm going to erase a couple things here so that I can tell you what to type in. So I'm going to write over here on the left-hand side. I want you to type in every single thing that I write, exactly how I write it, okay? And we'll see what happens. So anybody that wants to follow along is more than welcome. So you're going to hit the ln button first. A parenthesis pops up, okay?
Yeah.
You're going to type 5279, the division button, 4640, close parenthesis, enter. Tell me when you're that far. Okay,
I got
now,
0.12.
okay, I don't know. I'm not doing it live, but
Okay.
just hold off on that. So now leave that just as it is. Don't hit anything. Now hit the division button.
Okay.
Then you're going to put a parenthesis. Then the number 12. Then the ln button again, which that will pop a parenthesis up for you.
Okay.
Okay, then 1 plus, then 0.045, division button, the number 12, 2 parentheses, enter. And that should give it to you.
Okay, I got it.
Okay, so it's all about practice typing this thing in, okay? All right, so that was number 22. Let's see, what else that we have questions on with this one. Okay, I don't know, Lucas, if you can hear me or not. What type of calculator are you using? Are you using a TI 30, I think it was 31X? Lucas, can you tell me what type of calculator you are using? Anybody else having an issue getting this?
Yeah, I got an error too after I did the 2 parentheses at the end.
Okay, so do me a favor. What if, because everyone's calculator is different, and again, without me being able to see you with your calculator.
I have what Sydney has.
Oh, okay. And Lucas has the
Try
same
one more
one.
time.
Try one more
Mine,
time.
Mine was giving me the error because I kept forgetting to put the parenthesis in front of the 12.
Yeah, guys, she said, and that's a good point. She kept forgetting to put this parenthesis right here, and that's one of the reasons why the error was coming up. So,
Oh yeah, I didn't
Lucas,
do that.
okay, Lucas, try that again, because Taylor, you said you didn't do it. Try that again, Lucas, with this parenthesis right there, because you're right. That is going to give you an error because it's technically dividing by the wrong thing. So try it again. I'll give you a second. And then if that doesn't work, we'll meet in a bit, maybe one-on-one, because we just have a few more problems, and I want to really just two, and I'd like to get through them and then let people ask me the questions that they have.
Okay, I got it.
You did get it. Okay, good. All right, I'm going to wait just one more second, see if anybody chimes in, and then we'll move on. Okay. All right, so then everyone seemingly got that one. So then let's take a look at 23. Okay, so we're almost done. So on number 23, this is another equation that has logs. 23. And so we have log base 8 of x minus 3 plus log base 8 of x plus 6 equals log base 8 of 7x plus 3. Okay, so what's wrong with the way this problem is presented to us?
We have to condense the first part.
We have to condense, yes. Okay, so how are we going to do that? Since it's an addition problem, we're going to turn it into what?
Times.
Okay, so let's do that first. So since this is an addition problem, then I know that these two things are going to be multiplied. So I will have log base 8 of x minus 3 times x plus 6, and that's going to equal log base 8 of 7x plus 3. Now, the next thing that you're probably going to notice is this is one of the first problems where we've had a log on both sides. And we are allowed to have logs on both sides. And when we do, once we condense so that we just have one log on each side, we get to say, you know what, I don't really care about you right now because now I know that the stuff has to be equal. And so what I'm really going to do is I'm going to say, all right, well, x minus 3 times x plus 6 has to equal 7x plus 3, has to. And so from that, how do I, on the left-hand side, get rid of those parentheses?
FOIL.
FOIL. So let's do that. So we're going to get x squared plus 6x minus 3x minus 18 equals 7x plus 3. Perfect. And so now what we're going to do, since we have this x squared business, what's that tell me? How many answers am I looking for?
2.
2. And how am I going to get there? What do I have to do in order to get those 2 answers? I have to factor. And so I'm going to minus 7x and also minus 3 from both sides because I need this thing to equal 0. And so that's going to give me x squared. Now, if I have these 3 terms, which are the x values, if I have a positive 6x and I minus 3x and I minus 7x, how many x's am I left with here?
Negative 4x.
Negative 4x. Perfect. And then if I have these two guys right here, which are just whole numbers, if I have negative 18 and I minus 3, that leaves me with negative 21. And the whole idea is to get it to equal 0. And so now I have it in factored form. And luckily for me, I can factor this the normal way. And so I set my 2 parentheses out and I say, okay, I need 2 numbers that are going to multiply together to give me negative 21 while adding up to give me a negative 4. What are those numbers going to be? So what 2 numbers multiply to give me 21 and can add to give me the 4? How about a 7 and a 3? And if I need the negative 4 to be negative, that means my 7 has to be negative and my 3 has to be positive. And so then I'm going to cheat a little bit and I'm just going to quickly solve this and say, oh, well, x is 7 or x is negative 3. And what do I know about logs?
It can't be a negative.
And so if I were to take this negative 3 and I were to put it right here, guess what? This is still all negative. So this can't be. The positive 7 is my answer. Done. So my solution is just x equals 7. Done. All right. What do you think about this one? All right. Well, if you happen to look at number 24 on the exam or on the study guide, excuse me, this is the half-life problem. I'm not going to put that on the test. So we're finished. So you have to decide if you're done with me for the day. Do you have any other things that you want to look at? I have more examples of everything. You just have to tell me. What do you guys think? So
We're gonna do
yeah, if you're good. So listen, guys, if you're good, you're good. But if you have particular questions on something, please stay and ask me. Otherwise, the exam will open tonight at 11 or at 12:01, just in case you're a night owl, and it will be due Friday at 11:59 p.m. And I will message you in the meantime just to remind you. And before you start your exam, don't forget you have to go onto the onto Blackboard and get the formula sheet. You can either copy it down or print it or take a picture or whatever, but you're going to want that. You need that. And you definitely need a calculator. If you don't have a calculator, I recommend downloading the like the TI-83 graphing calculator app on your phone, because you need a scientific calculator. And some of the calculators that you have aren't super great. So what else? Anything else right now?
I had a few questions for the 7.5.
Okay. Anybody's more than welcome to stay. I'm just going to answer questions. So go right ahead.
On number 2, the one I messaged you about.
Yeah, I'm sorry about that. I was asleep.
No, it's fine. I'm just confused on how to work it out.
Okay, so we have 6 to the 3x plus 5, and that equals 36 to the 2x plus 9. Now, did you already do this one, and did you take the ln? Is that what you tried to do?
Yeah, I took the ln.
Okay, so you got a little bit ahead of yourself in the fact meaning that you didn't have to take the ln. Here's why. These bases, while they're not the exact same number, could we easily turn them into the same number?
Yeah, so like that 30x could be 6 squared, or
Exactly,
yeah, 6 squared.
exactly.
Okay.
So this is going to stay 6 to the 3x plus 5. This is going to turn into 6 squared to the 2x plus 9. And then this is just, hey, look, I'm ready to roll. No log needed. That's it. I wasn't trying to trick you guys. Okay, I just, just toss it on there.
Okay.
Now, if you happen to have done the ln, and had you done it the right way, you would get the same answer.
Oh, I just did it wrong.
Yeah. And I didn't look at your work, obviously, because I was asleep. So I don't know what you did or didn't do. But this particular one, no log was needed. So do you think now you could go back and get this one?
Yeah.
Awesome.
And then you just distribute that 2 into
Yep,
the.
you sure do. Mm-hmm.
Okay. And then number 4. So I know it's undefined, but like I started working it out, and then I got to 5 to the power of like 2x plus 4 equals x negative 5, or x minus 5.
Like this?
Yeah, and I didn't know like what to do after that.
Okay, so I'm not sure exactly how you got here, but we need to go back. There isn't even a 2x plus 4 in the problem.
Okay.
Let's go back to the beginning, okay? Because I'm not sure. So you started out with log base 5 of x minus 5, like that. And it was minus log base 5 of x plus 2, and that was equal to 2. This is the problem, right?
Right.
Okay, so when you're trying to solve this, you can only have one log on either side. Well, here I have 2, and so I have to do what with them?
Condense.
And I turn them into what based on this?
Divide.
Yes. So this turns into log base 5 of x minus 5 on top and x plus 2 on bottom, and that's still equal to the number 2.
Okay,
So
that's what I got.
That's what you got. Okay.
Yeah.
So now you're ready to draw your arrows.
Yes.
Okay. So this becomes 5 squared equals x minus 5 over x plus 2, like that. You got that?
Yep, that's what I got. And then I times it by x plus 2.
Okay, so let's do that.
Okay.
So let me get a different color here because I'm going to run out of room here. So you're going to do x plus 2 over here. This is what you asked me earlier, wasn't it?
Yeah.
Yeah. Okay, so let's pretend for just a second we know this is the number 25. So 25 times x, 25x. 25 times 2 plus 50.
Okay.
Okay? So my guess is you square this and you square that.
Yeah.
Yeah. Okay, we can't do that. We're multiplying. Okay? So then what will happen on the right-hand side is you still have x minus 5, and then from here, I bet you got it.
Oh, yeah.
Yeah, okay. So it was just a matter of you accidentally squared instead of multiplying. Easy fix.
Okay.
All right, anyone else or anything else? Anybody can chime in at any time. I'm just hanging out, working with you guys.
How do you know like when to take, like how the 5 squared is 25, but on number 2, like the 6 squared is just like you just take the squared part?
Okay, so Let me see. Let me go back. Let me clear this for a second. All right. So what you're asking me is on number 2. Well, we didn't just take the square part though. We did this. We had 6 to the 3x plus 5, and that was equal to 6 squared, and that was still to the 2x plus 9.
Yeah.
The reason, okay, so when we get the same base, this is the base, it's gone. This is the base, it's
Oh,
gone.
okay.
So I'm just left with the exponent part. This guy stays the same. This guy has to be multiplied.
Okay.
On number 4, since I didn't turn, let's see, how am I trying to say this? I didn't have bases in number 4, so to speak. I turned that right into an exponential function, so I didn't have anything to scratch out like this. So I
Okay.
had to keep the 5 squared equals blah, blah, blah. Because I didn't have, these two problems were different. Okay, they were set up differently, and I had to solve them differently. Okay?
Yeah. Yeah.
Okay. All right, anything else or anybody else? I still see a couple names in here. Anybody else have anything they want to chime in and ask me or tell me? Sydney, do you have any more?
Not yet.
Okay.
There's still a couple that I haven't finished. I might
Okay.
have questions on, but I probably won't get to it right now.
That's fine. That's fine. I mean, it's not due till tonight, and even if it's a day or so late, I'm penalizing you guys a point a day because I'd rather you do the work and be a day late than not do it. Okay, so even if it's not, if you don't have it done, it'll be like -1 or -2. Not a huge deal. Okay, but
Okay.
obviously I don't want it to be late.
Oh no, it'll be done by tonight.
Okay, perfect. All right, guys. Anything else? Because I'm done. If you're done, I'm gonna grade some more papers and get that feedback back out to you guys. And then that's it. So the test is out there, and that's all I got for you. So I think
So with,
pardon.
so with number 2, I guess, and 4, like what you guys were just doing.
Yeah.
Is that how, like, on the review, how you have to have it, with, like, minus the 18 and minus the 4x, and then have it all equal to 0,
Uh-huh.
and then you'd have to factor it out.
Yeah.
Okay. I was just wondering if that was like that similar question we did.
So wait, you're asking me on the review, which number on the review was that you were talking about just now?
We did like 23. Is
me
it similar to how we would continue working out number 2 on the worksheet?
Yeah, but on number 2 on the worksheet, since there's nothing being squared, you're not going to have to factor. You're just going to solve for x normally.
Okay,
On 23 on the review, since we have that x squared, that tells me I'm looking for 2 answers. That's how I know I have to factor. If you look at number 2 on the review, here it is done. Let's see if I can show it to you. Here it is. And so when you get to the step where we left off,
okay.
you can just see that there's x to the first power, which means 1 answer. And then you're just going to solve like normal.
Okay.
Okay. All right. Anything else? Okay. So then I'm going to go ahead and sign out, and I will upload this video to Blackboard in a bit. It takes a little while. And then you guys can just work on anything, and you can message me in the meantime. I plan on being home all day. So if I'm not napping or eating or outside with the dog, I'll get right back to you. Okay?
Thank you.
All right,
All right, guys. I'll talk to you later. Have a good rest of your day.